My dear student, you're welcome for another exciting session. And as we get ready to learn something to do with the limiting factor, and actually have an adopted question from KASNEP that was done in June 2013. And the question is asking us to determine a limiting factor and thereafter determine the production mix out of those particular limiting factors that we determine. Like before we actually look at the question, I would want us to go through into brief what we should expect as we go on. Like when we talk about a limiting factor, we are talking about these scarce resources that limit the number of units to be produced. Remember, resources in any particular organization will always not be that sufficient, will never be enough. At one particular point, if you have some resources, you'll find that some of them are not into the right supply, and therefore the number of units supposed to be produced will not be achieved at the optimum level. Like in this particular example, we are given products A, B, C, and D. Of these particular products, they are facing some constraints, that element of insufficient resources, and they're saying that these particular limiting factors could be things to do with the labor. For example, the labor hours may not be enough, as the number of workers may not be available in the right, as in the number of hours may not be availed according to the payment that is allocated. Then sales, you find that maybe the number of units that you can sell are again limited due to the fact that we have a limited market base. Then material could be another limiting factor. For example, the raw material that we are processing to actually produce our goods or our products may not be in sufficient supply. And then lastly, we have the machines. Remember, the more machines we have, the better the efficiency in that particular production. So if they are less in supply, it means that our production capacity may be reduced in that aspect. So what should we expect as we go through this particular example? We say that we determine the limiting factor by ranking the products in order of the highest contribution per limiting factor. And then now let us look at the steps now before we look at the question. Or I would like us to go through the question first. Like you're told, Gino Limited produces 4 products A, B, C, and D. So we have a product A, B, C, and D. We have the demands for each product all the way. Then we have the selling price per unit for each product again. Then we have the cost per unit. So the cost here, we are talking about material is one cost, labor is another cost, variable cost is another cost, and then the fixed overhead for each item. So ideally, if you look at these two costs here, we have these material and labor. Variable costs are not costs. Because now, one additional information, we are told that material cost is 10 shillings per kilogram. And the maximized farm has a total of 500 kilograms. So it means that there is no one particular point that this particular Gino Limited will exceed 500 kilograms for material. And then labor is paid at 10 shillings per hour and is limited to 360 hours. And then from this particular information, we should understand that this particular company cannot pay beyond 360 hours. So it means if we do our working as we are going to proceed and find that the labor is either more than 360, it means it is limited. But again, now you find that we compare again the kind of kilograms that you're supposed to produce versus what we have, and then see which one is lower and determine whether it is limiting or not limiting. Then we're told, determine the limiting factor. Then part B, calculate the production mix that would maximize profit for the month. So our working is going to encompass two particular steps, and I would like us to begin. So normally what we have, like in this case, you're supposed to determine, step 1, determine the factor that is limiting. And out of the question, we are talking about additional information. We are using material and labor. So if you talk about material and labor, with part A, we're supposed to determine whether material or labor is a limiting factor, because that is what we are given as the availability of hours that should not be exceeded is a limiting factor. Then now from this one you can start now talking about now material. When you're doing this, I want us to get actually what is known as the number of units. Like you see, under material, for A, product A, we have 1200 units which was budgeted. For B, 1200, 800, and again 1200. So we are going to calculate actually how many units of each product do we require the material, or how many kilograms. Like now you're told material cost 10 shillings per kilogram. So you want to see how many kilograms can we produce by this. If 1 kilogram costs 10 shillings, what about this? I mean, if 10 shillings cost 1 kilogram, what about this budget that was planned for? It means you're going to divide each element here by 10. Like now we talk about for A, we can talk about now this 1200 per 10 over 10 shillings, we get a value of 120 kilograms per unit. We do for B, we get 1200 again over 10, we get 120 kilograms per unit. If we proceed all the way, we shall have 800 for C over 10. Over 10 is supposed to be 80 kilograms. Oh, this one was 1200, supposed to be 80 kilograms per unit. And finally we have D, which is actually 1200 over 10, which is 120 kilograms per unit. So if you do all the summation, you're supposed to add all these kilograms here, and when you add, you get them that shall have 120. Of course, they are 3 times 3 plus 80 for 40. So this is what is required. For 40 kilograms is what is required. So the required kilograms is for 40. We required for 40. But you're told that it has a total of 500 kilograms for material. But now available is 500. So we find that what we require is less than what is available. In other words, there is no shortfall. So here there is no shortfall. Shortfall means this particular company or a particular organization can comfortably work with what is available to produce material as a factor in production. After doing that, we can now consider this part that is now requesting us to do something to do with now labor. So if material is there's no shortcut, it means that material is not a limiting factor, we now proceed to labor. Let us do for labor now. For labor, we shall proceed with the same procedure that we've done. We are told that labor is paid at 10 shillings per hour and is limited to 360 hours. Again now, under labor, we have 15 for A, 800 for B, 600 for C, and 1200 for D. So for A, we shall have a value of, as I've read, is 1500 over 10. We get a value of 150 hours per unit. B, we get a value of 1200, as I read before, over 10. We get 120 hours per unit. B was 80, B was 80, so we have 80. Then C is 600, C is 600. Over 10 we have 60 hours per unit. And then we have D as a product, we have 1200 over 10 is equal to 120 hours per 1 unit. So if we add all this, we're supposed to get what is required, the number of hours that are required versus what is available. So what is available is actually 360 according to the question is available, but how much is required? We require 150 plus 8, that is 230. 230 plus 8 is 290. This is 230, sorry. 230 plus this one, 290. 290 plus 120 is 410. 410. Now you see what we require is 400, but what is available is 360. So it means there's an excess. It means there's a shortfall. There's a shortfall beyond what is available. So there's a shortfall, and therefore labor is limiting. Now, after determining out of the resources that we have which one is limiting, we shall now proceed to the next step, in which now we determine now the optimal mix of the limiting factor, then rank. And when you're doing the ranking, we are doing the ranking from the highest contribution per the limiting factor. So if you go to step 2, I would want us to actually talk about determining the optimal mix now, according to what I've illustrated. Determine the optimal mix, that is part B. The optimal mix. And we talk about now optimal mix, I want us to understand something. It involves some aspects of getting the contribution. We have something to do with the contribution, and contribution will normally be given by the profit minus the variable cost. The profit minus the variable cost. As we all know that if you look at our question, you'll find that we are supposed to have some elements of selling price. This one contribution should be the sales. It should be the sales. Sales minus variable cost. That was a mistake on my side. Sorry for that. is supposed to be the sales minus the variable cost. And as you can see here, you talk about now the variable cost, we are going to talk about the element of, from material A, for example, we shall talk about now the element of material, labor, and the variable cost which is given in this particular question for each particular product. So we can have now for material product A, under product A we have its sales. The sales are given, and when the sales are given, it means that we can easily determine. So we can have material A, then we have the sales. Its sales are given as 3840, that is per 1 unit. B, C, and D. So for B, its sales are 2700. C, the sales is 2000. 2000. Then D, the sales is 4000. We're supposed to less. We less now the variable cost. Less the variable cost. And our variable cost here has so many components. Like we have the variable cost is material. The first one is material. For A is 1200. Labor is 15. Then variable overhead is 240. So we shall have 1200, 1500, then 240. These are the variable costs that we're going to less. When we less that one, we less all these amount from this particular amount. When you add all these and less from the sales, you're supposed to get the contribution, sales minus variable cost. So we get the contribution, which should be 900. Kindly confirm with me. Then for this one, for B, we shall have 12,870. Shall have 12,800 for material, labor. Then we have 170. Remember, fixed cost does not form part of the variable cost, so we don't. So when we less this from that amount, we're supposed to get a value of 530. Then we have this particular working again. For C is 800. We less 600. We less 100. When you less these three from that, you're supposed to get a value of 500 shillings. 500. Then finally we have 1200 minus 1200 again minus 200, and then we get a value of 1400 shillings. 1400 shillings. That one is now our optimal contribution mix. Then we go to the contribution of the limiting factors now. Now, because now we had the limiting factors, we are now going to determine the contribution. So contribution of the limiting factors, contribution of the limiting factor. And for you to get the contribution of the limiting factors, it's fine that this contribution you're seeing here are actually in terms of units, and we are told that for A, for example, we have 120. For B, we have 200. The contribution of each limiting factor of each product in the limiting factor, and the limiting factor happens to be labor, you find that these are now the contribution, but now 1 unit of A is equal to 150 hours. What about now 900? Or you see that 150 hours is equal to 1 unit. What about now the 900? So for us to get for each limiting factor, for example A, it will be this 900 contribution divided by 150. You get a value of 6 hours. 6 hours per unit. For B, it will be 500. 500 divided by, this was 80. You get a value of 6.625. 6.625 hours per unit. Then C, we have a value of 500 again. Contribution 500. Hour per unit, hours per unit is supposed to be 6, so you get divided by 60, you get a value of 8.33. 8.33 hours per unit. Then finally we have D. We shall have contribution of 400. You divide by limiting factor of 120, and then you shall have a value of 11.66. 666 hours per unit. Kindly confirm with me if they are accurate. And then now, under our steps, we are supposed to rank as per the limiting factor. And when we are talking about the ranking, we normally start with the highest. You do the ranking of the products in order of the highest contribution per limiting factor. So the one which has the highest contribution will be ranked first. Like you see here, we have this one is our first rank. Second rank will be this one, C. Third rank will be this one. Then the fourth rank will be that particular case. So we have the steps or the ranks. So we have the ranks, the ranking. As I've said, you shall have number 1, 2, 3, 4. Of which in number 4 we shall have the first one, which is actually D, as we have illustrated. Second is C, third is B, then the fourth one is A. Then now we are supposed to do now the allocation according to the ranks that we have actually calculated. After doing the ranking now, I would want us now to go ahead and now formulate a new table which you are going to have the ranks, which is actually 1, 2, 3, 4. After the rank, we are going to have the product. So you have the product. First rank is D, second rank is C. C as given here. Third rank is B, and the fourth rank is A. We just copy paste. Then next is supposed now to have now the hours required. The hours required. The hours required. So we talk about these hours required. We now go to the contribution of the limiting factors as per the hours that was required, and of course we computed those particular hours according to this one. So for D, we are going to require, according to the first round, we are going to require 120. hours per unit, that is under the hours required. For D is 120 units. For C it is 60. C is 60. Then for B, the next one should be 80. Of course, for A, it's supposed to be 150, but under limiting factor consideration, the last rank, according to the lowest contribution, like we saw it was A, will not be allocated these 150 hours. Instead, it will be allocated less 150. It must be less because we realized labor is a limiting factor. And of course, now to be more specific, we are going to narrow down to product A that will not be allocated 150. If you allocate 150, it means that actually there was no limiting factor in the first place. So how do we get how much to allocate? If not 150, it must be less. It means that now we talk about now the cumulative now. Cumulative hours. Cumulative hours will actually give us how much to do. And cumulative simply means we normally add the values the way they are. Like you have 120, the first is 120. Next value here should be 120 plus 60, which is 180. Next here should be 180 plus 80, which should give us a value of 260. And then of course the next one, because we should not exceed, because our hours in this company should not exceed 360, it means that our next cumulative hours should be 360. That is the maximum that we should actually allocate in this particular working. So how do we get the number of hours to allocate here? It is very simple. How are we getting this one? How did we get this? We added this 180 to 80 to get this one. So for us to get this, we add 260 plus x is equal to 360. So it means our x here is 360 minus this. Because actually getting this is this one minus this. So for us to get this is 360 minus 260, which is 100. And our 100 is what we are supposed to produce in that particular product A. And actually these 100 will be sourced from external, to be sourced from external, or if like the excess, which is 150, which is 50, 150 minus 100 should also be sourced from external capacity to be able to establish this particular production to run smoothly. Then now we are not yet done. After now getting the number of hours to produce for A, we should ask ourselves from the question, and our question is very simple. We say that you find that here we need the demands per that particular product that we have actually reallocated is 1,500 units. 1,500 units. But you find that as per product A, what is required for product A is 150 hours per 1 unit. So you say that if 150, this is for product A, if 150 hours is equivalent to 1 unit, what about the 100? What about that 100 that we have actually determined? Reason being should not exceed 360. What about 100 hours? Should be 100 times 1 over 150. And of course we are going to get 100 divided by 150. We get 0.6 66666, so when you round off. But now, those are the number of units that are required for this particular product for 1 unit, shillings per 1 unit. But now again, the question is asking us, or we are being told that demand per one in units is 1500. So you're supposed to get the overall demand. We multiply that one, 0.6667 times 15, to get actually the number of units that are required as per the rescheduling, as per the limiting factor module, which will be the answer times 1500, we get 1000. So we need 1000 units for A. After that, I think we're supposed to be through with that particular session. The next thing I want us to do is the production mix that would maximize profit for the month. Now, for us to get how much profit is supposed to be maximized, we normally talk about, you subtract the sales minus all the costs. Now we are now going to talk about, now we shall now involve the element of fixed cost. We shall even subtract the element of the fixed cost in this particular scenario. So the production mix that will maximize the profit, we normally talk about sales first. We have for A, for B, for C, then finally for D. So sales as per A, we are told that they are 38,400. So 3840 times 1000 units which are required, we shall get a value of 3840, then 3 zeros. For B, it should be the selling price, which is 27. So B should be 27 times how much? The demand. We sell as per the demand, but in this one we sell as per the units required, which is not 15, instead it was 1000. So B should be 27 times 800, 1800. So 2700 times 1800. C will be 2000 times 1000, of course up to 2 million. Then D finally shall have a value of 4 million times 4, 4000 times 4000, selling price as per the demand. Then now we are supposed to have a value of something to do with, so this one shall be 16, 2, 3, 4, 5, 6, and this one should be 27 times 1800. You get a value of 4.860,000. 4,860,000. These are now the sales. We can now let's factor in now. Now let's factor in the element of all the costs. We've now less the variable cost. So when we less variable cost, and our variable cost, the first one, is material. For A, again we are going to talk about the 1000 units which was computed. So it should be 1000 units times 1200. 1200, we get 1.2 million. B, we again now have an element to do with 1800 times 1200. 1200. So it is now the demand as per this particular units available. So it should be 1200 times 1800. C should be material which is 800 times 1000, 800 times 1000. Then D we have 1200 times 4000, 1200 times 4000. You're supposed to get a value of, when you multiply this two, for this one has been multiplying these two, you're supposed to get a value of, for B you're supposed to get a value of, you can work it out, 1800 times 1200, 2,160,000, 2,160,000. Then this one you shall get a value of 800,000. 800,000. When you multiply these two, you're supposed to get a value of 4.8 million. That is the material. Then now we go again to another variable cost, which is labor. Again, labor for A, it's supposed to be 1,000, not 15. 1,000 units times 1,500. 1,000 times 1,500. For B, it should be 1,800 times 800. 1,800 times 800. C is 1,000 times 600 times 600. 4,000 times 1,200. The last one is 4,000 times 1,200. Because again, when you multiply this one, supposed to get a value of, this is same as 4.8 million. Is supposed to be 600,000. This is supposed to be 18 times 8, 144. Then we have the 4 zeros. Here we have 15, 1.5 million. Then lastly we talk about, not last but least, but we are supposed to talk about the element of the contribution now. Contribution here is now the variable overhead. The variable overhead, which according to this question we have the variable overhead here. Now our variable overhead should be the contribution, and define that. In our working that we had before, we are supposed to determine our contribution. For A, we allocate the resources according to A, and our A contribution was 900. So it's supposed to be 900 times the 1,000 units. So it is 1,000 units times 900. Okay. Reason, we won't multiply with this particular 240 because we've realized that our contribution as per the demand of 1,500 is actually 1,000 and not 240. So it will be 1,000 times 900. Then for B, it should actually remain 1,800 will not be affected. 1,800 times 170 times 170. For C again will not remain which is 1000 times 100 times 100. Then finally for D should be 4000 times 200 times 200. Then finally we talk about now we less the element of all the fixed cost. So we less the fixed cost, and our fixed cost we are told that is 600 for A, but now the units required for A is 1000, so it's supposed to be 1000 times 600. B, it's supposed to be a value of 1800 times this 500 times 500. C is 1000 times 400, 1000 times 400, and then D is 4000 times 600, 4000 times 600. And then now when you do the working, like here we are supposed to have 900,000 for contribution. Here is supposed to have 18 times 17. You have 306. 306. 1, 2, 3. Then here is supposed to have a value of 100,000. Here we have a value of 8, 3, 4, 5. 3, 4, 5. So we have 800,000, 306, and 900,000. And then now this one is supposed to have something to do with 600,000. Here we have 90, 900, 900,000. Then we have this is a value of 400,000. In this case we shall have it is 24, 2, 3, 4, 5. So it should be something to do with 24 million. That is for the last particular session. It should be 2.4 million, not 24 million. It should be 2.4 million. 2.4 million. So as we do as we find that now